Alright, so in this activity here for 19.1, probability of set theory, calculating theoretical probability. So we're going to be calculating not only the probability of a certain event A happening, just to review some of the vocabulary. So this is the union versus the intersection of A and B. So remember, this is more of what they have in common. This could be in either A or B. And then this is, of course, everything that's not A. Okay, but we first have to know what these events are. So first things first, it says you roll a number cube. So that looks like a 6-sided die. Okay, because a cube has 6 sides. And event A is rolling all prime numbers. Event B is rolling an even number. So let's go over that. So even numbers would be 2, 4, 6, 8. Whereas prime numbers are pretty much numbers that, you remember, they're kind of like odds, but not quite. So, like prime numbers would include, as you can see from the picture here for A, that would include 2, 3, and 5. Okay, and the reason why I don't go up further is because remember there's only 6 sides to choose from. In fact, our universal set, our numbers to choose from are 1, 2, 3, 4, 5, 6, and you're like, why does she only go up to 6? Because there's only 6 sides on a cube, just in case you forgot. Alright, so they draw the picture out for us. We don't have to do that, not yet anyways. So there's 3 for A. See, it's right there. For 5, also in A. And notice how 2 is actually, since both of them have a 2, it's kind of in the middle because that's what they share. That is their in common. Whereas for B, we only put 4 and 6. I don't know why I picked 8 because, again, it doesn't go up to 8. There's only 6 sides, right? And you'll notice that 1 is a part of the universal set, so it's going to stay out here. They didn't use U. They used S for sample space. Which, I mean, you can use either S or U for universal set. Either one's fine. So this is good, and then that's good as well. But let's see. Okay, so now we have this Venn diagram. Let's see if we can figure out our probability for probability of A. So the result, again, there's only 1, 2, 3, 4, 5, 6 total results that could occur. And in fact, that's going to be the case for all of these as I'm seeing this. So that's 6, 6, and then for the last one, P of A, I'll go ahead and write this here. For our complement, again, out of 6, right? So for A, how many blocks or results end up in A's section? That's 1, 2, 3. And yes, you should reduce it, but I'm going to move on. Alright, so now let's figure out what's the probability of what they have in common. Alright, they have kind of in the middle, which is that shaded region between A and B. How many blocks are there? 1, right? And then last but not least, for here it's the union. It could be either or. So how many blocks are in A, including the middle space, and how many blocks are in B? So let's count those up. 1, 2, 3, 4, 5. There's 5 blocks in either A, in common, or B. And last but not least, for what is not A. So for this, I'm going to kind of change colors a little bit. So I'm going to highlight everything outside of A. And that includes the sample space and everything in B. Now notice how I'm totally ignoring A. I'm not even going to draw in A at all. I'm just going to draw around it. So let's count up how many blocks are not, again, not in A. Go ahead and count those up right now. And you can see that's 1, 2, 3. 3 blocks that are not in A. Again, make sure you're reducing these, like 3, 6 does reduce. And 3, 6 also reduces. In fact, what does 3, 6 reduce to? 1/2, right? All right, let's move on to part B. In fact, we were doing that already on the last page, so I'm going to skip that. All right, so again, we're going to calculate probability of A, either the union, what they have in common, A and B, and what's not in A. So first things first, let's read the situation so we can identify our A and B. So your grocery basket contains 1 bag of each of the following. So it includes either oranges, green apples, either green grapes, it's a lot of green stuff, either green broccoli, cauliflower, orange carrots. I'm sure the color makes sense, or will probably matter later on, so I'm going to copy that down. Again, orange carrots. It's a lot of stuff. And then I think, last but not least, green spinach. All right. So out of the whole universe, there's like 1, 2, 3, 4, 5, 6, 7. Not numbers, but food items to choose from. Okay. You're getting ready to transfer your items to the cart on the conveyor belt. Let's say event A is you picking a vegetable first. So veggie table. Event B is picking a green food first. Well, that's a little bit easier to identify. Let's go ahead and identify all of our green foods. And just from this universal set. So that would be the green apples. I'm going to write G for short. The green grapes. The green broccoli. And the green spinach. Okay, so there's 1, 2, 3, 4 that actually happening. For vegetables, that would be either broccoli, cauliflower, carrots, or, I ran out of room, spinach. Spinach. All right. All right, let's go ahead and put this in our Venn diagram. So A is either, for us for the vegetables, that would be either spinach. I'm going to put abbreviations so I can fit everything on there. That would be broccoli, carrots, or cauliflower. As you can see here for B, that's going to be apples, grapes. Now I noticed that broccoli, as I'm going to highlight that for you, broccoli appears here and here, and spinach also appears in both. So I'm going to move some of these words, spinach and broccoli, to the middle right now. So we'll put spinach and broccoli, since they both appear in A and B in the middle. First things first, let's go ahead and count up for probability of A, for A and B occurring, for A or B occurring, by first figuring out how many number of items there are in the universal set. So count them up. How many number of items are there for a universal set? And that would be 7 total. Alright, so I'm going to put 7 down for all of those results. And let's go ahead and count up how many are actually in, I'm going to pick a different color, in part A. So go ahead and count all those up. And how many items are those? That would be 4 items. Okay. On the next one, for this one, this is what they have in common. So how many items do they have in common? 2, right? Last but not least, well, second to last but not least, what they have in either A or B. So I'm going to highlight in the different colors so you can see the difference. So this could be in A, what they have in common, or in B. So how many items do they have in common? And what they have in either A or B? That would be 6, right? 1, 2, 3, 4, 5, 6 items that they have in either A or B. And last but not least, we're going to figure out the probability of calculating what's not in A. So let me just copy from the last screen on from here to over here. And as I was recording this down, I noticed that every single part of these have a place in either A or B or what they have in common. I forgot to put in the universal set for orange, because orange is there, which is not to be confused with orange carrots. They're very different. Alright, so again, there's 7 total possibilities that it could happen, and again, I'm just going to highlight whatever's not in A so we can count that up. Alright, so I'm going to go ahead and color everything not in A, which is orange, apples, grapes, and notice how I'm totally ignoring what's in A. Alright, so how many items did I just highlight that's not in A? And that would be 1, 2, 3. 3 results that are not in A. Alright, just like it says here, stop and do the problems in the packet. I'll come back to go over, explain 2 in just a moment, but go ahead and stop and do some of the problems in your packet. Feel free to use some of the space provided. That's not in your packet, but you can draw this out for yourselves.